All right, good morning, guys. Today we're going to be covering 9.2 areas of trapezoids and kites. So let's go ahead and jump right in. So first off, a trapezoid. If we recall what a trapezoid is, it has one set of parallel sides. So every single time that we have a trapezoid, we'll always have a set of parallel sides shown. Now, if I want to find the area of this trapezoid, I can use the area formula. Area is equal to 1/2 our height of the trapezoid times base 1 plus base 2. Now, if we recall, height of a quadrilateral must always be perpendicular to the base. So therefore, it must always intersect the base at 90 degrees. If it's not intersecting at 90 degrees, it's not a height. As for our bases, base 1 and base 2 can always be found on the trapezoid itself. It will always be the parallel sides. And it doesn't matter which one you say is base 1 and base 2. It's up to you to determine that. So I'm always going to call the top one base 1 and the bottom portion base 2. And that will always be the case. Now, important here, h is the distance between the parallel sides, and b1 and b2 are the length of the two bases. This formula, the way that we came about this formula, it comes from splitting the trapezoid, the whole thing, into a parallelogram and a triangle. And of course, we have different equations for each of those. For a parallelogram, we have base times height. And for a triangle, we have 1/2 base times height. If I were to add those two together, that would give us the equation area is equal to 1/2 times the height times base 1 plus base 2. So that is where these formulas come from. Now, another area formula for a trapezoid deals with the median. Recall that the median of a trapezoid is a line that connects the two midpoints of the legs of a trapezoid. So if I have two midpoints, again, a midpoint is right in the middle, meaning that's split up perfectly on either side, so it's congruent on both sides. If I have two midpoints and I were to connect them to each other, that segment that connects the two midpoints is called the median. So the other way that I can solve for the area of a trapezoid is through finding the median. Now, in order to find the median, I just take the average of my bases. So if my bases are 20 and 32, I just add those two together and I divide by 2. So in this case, I would have 20 and 32, and when I add those together, I get my median is equal to 1/2 of 52. Well, 1/2 of 52 will just leave us with 26 units. So the length of our median, the length of this segment here, is 26 units in length. If I want to find the area based upon that median, I would just take the median, 26 units, and I'd multiply it by the height of our trapezoid, because that's the only thing that's missing from this equation to get the area of a trapezoid. It's missing the height. So if I multiply the median times the height, I'll be left with the area. Well, 10 is our height, 26 is our median, so we're left with 26 times 10 for our area. Well, 26 times 10 is just 260 units squared. So that is the other way that we can always find the area of our trapezoid. Now, we're going to go ahead and find the area of this trapezoid to get started. And I'm going to show you two different ways to do it here. The first way is to split it up into multiple shapes. So if I look over here, I see that these two sides are both parallel and congruent. If that's the case, that means that this is a parallelogram right over here. And with a parallelogram, I know that opposite sides are congruent. So this would be 2 as well, and this would be 4. Over on the other side, we have a trapezoid. So again, we have a parallelogram and a trapezoid. The first way that I'm going to show you guys is I'm going to break these into two shapes, the parallelogram and trapezoid, and I'm going to find the area of each. Then I'll just add those together at the end. For our parallelogram, the area is equal to base times height, and for our trapezoid, it's 1/2 times our height times base 1 plus base 2. Looking at our parallelogram, we can see that our base is 2 in length, and our height is 3. Again, 4 is not a height here because it is not intersecting at 90 degrees. 3 is intersecting at a 90-degree angle, making it our height. As for our bases, for our trapezoid, base 1 for our trapezoid is 7, base 2 for our trapezoid is 9. And again, the height of our trapezoid is also 3. Plugging in our values, we're left with the area of our parallelogram is equal to 2 times 3 plus the area of our trapezoid, which is 1/2 base 1, 7 plus base 2, 9 times the height, 3. Well, 2 times 3 is 6, and then 7 plus 9 is 16. Half of 16 is 8, and 8 times 3 is 24. So I'm left with 6 plus 24. Well, 6 plus 24 is just 30 units. So therefore, the area of the shape is 30 units squared. The other way that you can solve for this is by first combining what we have in the picture. And what we notice is that this is just one big isosceles trapezoid. So therefore, base 1 I can call 9 units. Base 2 I can call 11 because 2 plus 9 gives me 11. So therefore, I can use area is equal to 1/2, 3, our height, times 9 plus 11, our bases. Well, 3 times 9 plus 11, which is 20, just gives us 60. And half of 60 is 30 units squared. Either way, we get the same exact answer. So it's up to you to determine which method you prefer. Next up, we want to find the area of this trapezoid here. Now, again, we can look at this trapezoid, and right away we notice that this is an isosceles trapezoid. Opposite sides, we have one pair of opposite sides that are congruent, and further, those sides aren't parallel. Now, we also see that we have a 30-degree angle, which means that we have a 30, 60, 90 triangle. And that's the same on both sides because, again, these two triangles are similar. Or sorry, not similar, but they're congruent. They're congruent triangles by angle, side, angle. Now, that also means that we have a rectangle in the center, which means that this opposite side within the rectangle is 8. So what I want to do is I'm going to draw a working 30, 60, 90 triangle so that I can solve for this part of my base down here and also for my height. So looking at our 30, 60, 90 triangle and the triangle that's given, the only side that we have matching is 2x, which matches with 10. So 2x is equal to 10. That means that when we solve for x, what do we solve for? Well, we'd be solving for the height. So x, solving for x, would give us x equals 5, so the height of our trapezoid is 5 units. Next, I need to go ahead and find the missing part of our base, because again, I only have 8 for this center portion. I need these portions as well. So I can do that by solving with our special right triangle. I see that this portion matches with x radical 3, and since x is equal to 5, both of these segments are 5 radical 3 in units. So both those lengths are 5 rad 3. Now we can finally use our area formula. Area is equal to 1/2 our height, 5, times base 1, 8, plus base 2, 8, plus 5 rad 3, plus 5 rad 3. That will leave us with area is equal to 1/2 of 5 times 16 plus 10 rad 3. At this point, I distribute through the parentheses. 5 times 16 is 80. 5 times 10 rad 3 is 50 rad 3. Lastly, I take half. I distribute the half through the parentheses, giving me 40 plus 25 rad 3 units. If we enter that into a calculator, we'll be left with about 83.3 units. Squared, of course, because it's area. And that is our final answer. All right, next up. Now, we want to find if a trapezoid's perimeter is 55 and the non-parallel sides are 6 and 9 in length, we're given a height of 5, we want to find the area. Now, ignore the answer down here. We're going to go ahead and find the exact answer rather than the decimal answer. So, to get started, we're going to draw our trapezoid. And again, our non-parallel sides are lengths 6 and 9. We have height of 5, and I'm going to show you guys how to get this radical 11 over here. So in order to get that radical 11, we're going to use Pythagorean's theorem. That's a squared plus b squared equals c squared, where I'm going to go ahead and say that this bottom portion, this radical 11, is x. Our height, 5, is a. and our hypotenuse 6 is C. 5 squared is 25, 6 squared is 36. Subtracting 25 from 36 will leave us with x squared equals 11. If we want to solve for x squared, we take the square root of both sides, leaving us with x equals the square root of 11. Next, we're going to do the same thing to solve for this missing portion of our base. So to solve for this missing portion, I'm going to go ahead and call this y. And I'll have y squared plus 5 squared equals 9 squared. 5 squared is 25. 9 squared is 81. If I subtract 25 from 81, I'll be left with y squared equals 56. Lastly, taking the square root of 56 will leave us with y equals radical 56. And we'll leave it with this answer for right now. We won't simplify it. Lastly, we need to find the top base, which will also allow us to find this missing portion of our bottom base. And to do that, I'm just going to go ahead and give these a variable. I'm going to say that both of these are the variable z. From there, I'm going to use that the perimeter is 55 in order to set up this equation. 6 plus z plus 9 plus radical 56 plus z plus radical 11 is equal to our perimeter of 55 units. Z plus z is 2z. 6 plus 9 is 15. 55 minus 15 is 40. So I'm left with 2z plus radical 56 plus radical 11 equals 40. If I subtract radical 56 from both sides, radical 11 from both sides, and divide both sides by 2, we're left with z equals 5.4. Lastly, we can plug this into our area formula. Area is equal to 1/2 our height, 5, times base 1, 5.4, plus base 2, 16.2. Again, if I add radical 11, radical 56, and 5.4 together, we get 16.2. 5.4 plus 16.2 will leave us with 21.6. 21.6 times 5 will leave us with 108.02. Half of 108.02 will leave us with 54.01 units squared. And that's our final answer. All right, next up. The consecutive sides of an isosceles trapezoids are in the ratio of 5 to 4 to 5 to 10, with a perimeter of 48. We want to find the area. So first off, this is an isosceles trapezoid, so I can draw one on. And then since it's consecutive sides, it's one after the next. So it's going to go 5x, 4x, 5x, and 10x. Now I'm getting the x's because these are all in a ratio. If something's in a ratio, I should always put a variable next to it. Further, I know that if I add up all my sides together, it'll equal 48. So I can say 5x plus 4x plus 5x plus 10x equals 48. Combining all of these like terms will give us 24x equals 48. Dividing both sides by 24, 48 divided by 24 will leave us with x equals 2. Now that I have x, I have all the sides of each section of this trapezoid. So therefore, our legs are both 10 units in length. The top base is 8. The bottom base is 20. From here, I'm going to go ahead and cut this so that I can go ahead and find the height, because 10 isn't our height because it's at a slant. So I'm going to go ahead and draw a perpendicular line, making right triangles. And since the bottom and the top of this rectangle are congruent, and the whole thing was 20, if we recall, this whole length right here is 20. Well, since these are both going to be the same, they're both 8, that means I have 12 left over for each triangle here. And if I have a total of 12 for each congruent triangle, they should both get 6 for these sections of their legs. From here, I should be able to find the height of this triangle using Pythagorean's theorem. 6 squared plus h squared equals 10 squared. Now this is a special right triangle. This is a Pythagorean triple of 6, 8, 10. So therefore, h will be equal to 8, and you'll see that as soon as we finish up Pythagorean's theorem. 100 minus 36 is 64. The square root of 64 is 8. So some of these you'll be able to look at, and if you know your Pythagorean triples, you'll be able to look at it and be like, oh, that's 8, or oh, that's 5, or 4, or whatever it may be. Some of them you'll actually have to do the math, though. Now that we have our height, we can plug it into our area formula. Area is equal to 1/2 of our height, 8, times base 1, which is 8, plus base 2, which is 20. 20 plus 8 is 28. 1/2 of 8 is 4. 4 times 28 will leave us with 112 units squared. All right, next up. Next, we're going to talk about the area of a kite. So, the area of a kite is based around the fact that a kite's diagonals are perpendicular, meaning that its diagonals are intersecting at 90 degrees, making right triangles for each section here. Now, along with that, we're going to use the diagonals to divide the kite into 4 right triangles. And what I'm going to do is I'm going to take these 2 triangles on the bottom, and I'm going to rotate those triangles to make 2 rectangles. So I'm just going to rotate them up to the top here. And what it will look like is something like this. So you see that we have these teal triangles and these blue triangles rotating upward. And now I just have a rectangle. This leads us to the area of a rectangle. That area is equal to diagonal 1, which again is just this full length here for our kite, because that's diagonal 1, times diagonal 2 over 2. And the reason that's half of diagonal 2 is because when I rotate, this section of my triangle, the half of the diagonal, rotates up here to just be on the outside. So therefore, this isn't the full diagonal for the area, it's just half of that diagonal. So that's why it's diagonal 2 over 2. That leads us to the area formula. Area of a kite is equal to d1 times d2 over 2, where d1 is diagonal 1 and d2 is diagonal 2. Now, you should also remember here that a rhombus and a square are also kites. For a shape to be a kite, consecutive sides need to be congruent. 2 pairs of consecutive sides must be congruent. And since rhombi and squares both have that, I can use this equation for those as well. But it's mostly going to be used for kites. So, let's go ahead and try out some examples. First, we want to find the area of this kite. Now, something that may be a red flag right away when you look at this is this 30-degree angle. This 30-degree angle may make you be thinking, oh, this is a 30, 60, 90 triangle, which it is. But I don't actually need to use this 30 degrees because this is a kite. In a kite, one of the diagonals is being bisected. And so this diagonal that's being shown with a segment length of 4, that is the segment that is being bisected. So this bottom portion should also be 4 in length because, again, they're congruent. From here, we can use our area formula. Area is equal to diagonal 1 times diagonal 2 over 2. Diagonal 1 will be 4 plus 4, which is 8. Diagonal 2 is 12. So we're left with 8 times 12 over 2. 8 times 12 is 96. Half of 96 is 48 units squared. So the area of this kite is 48 units squared. Next up, find the area of a rhombus whose perimeter is 20 centimeters and whose longer diagonal is 8. So first off, I have a rhombus here. So in a rhombus, we should recall that the definition of a rhombus is it's a quadrilateral with 4 congruent sides. So therefore, all 4 sides are congruent. And if the perimeter is 20, and I have 4 congruent sides, that means that all 4 sides are 5 centimeters in length. Well, if we know that each side is 5 centimeters, I can also draw my diagonals in. And drawing those diagonals in will create 4 right triangles. All 4 of those right triangles being congruent. Further, the longer diagonal is 8 units in length. And since it's a diagonal in a rhombus, it's being bisected. So each portion gets 4. Now, if I focus in on this triangle up top, I see that I have 2 sides of a right triangle, so I can solve for our third side using Pythagorean's theorem. Now, this is also another special right triangle. It's a Pythagorean triple, so you may be able to solve for that missing side just by looking at it. And if you do, you'll notice that y is going to be equal to 3, because this is a 3, 4, 5 triangle. 4 squared is 16, 5 squared is 25, 25 minus 16 is 9, and the square root of 9 is 3. So again, this is a 3, 4, 5 triangle, and that is one that you should be able to pick up and look at and be like, oh yeah, I can identify that as a 3, 4, 5. Now that I know that y is equal to 3, I can plug it into our area formula. Area is equal to diagonal 1 times diagonal 2 over 2. Diagonal 1 is 8. Diagonal 2 is 3 plus 3, or 6. So we're left with 8 times 6 over 2. 8 times 6 is 48. 48 divided by 2 is 24 units squared. Sorry, centimeters squared. I'm not dealing with units here, dealing with centimeters. All right. Next up, Q is a kite. Angle UTE is a right angle, so this is 90 degrees here. UE is 14. CE is 25. So we can go ahead and draw everything that we have here. If UE is 14, then that means that each portion is 7 and 7. And we have a 90-degree angle here, which means that if this is 45 degrees, this must also be 45 degrees, making both of these into 45, 45, 90 triangles. Because again, diagonals are perpendicular, and by the no-choice theorem, this must be 45 degrees. Well, if you recall, in a 45, 45, 90 triangle, the sides opposite 45 are x in length, and the side opposite 90 is x rad 2. So therefore, since x is equal to 7, that also means that this other segment from point T to the intersection point is also 7 units in length. Now, in order to solve for this other portion of this diagonal from point C to the point of intersection, I'm going to use Pythagorean's theorem on this right triangle down below here. So that'll give me 7 squared plus our unknown length, y squared, equals 25 squared. Now this is another Pythagorean triple. This is a 7, 24, 25 triangle, but let's go ahead and solve for it right now. 7 squared is 49, 25 squared is 625. 625 minus 49 will leave us with 576. The square root of 576 will leave us with 24 units. Now, we can finally use our area formula. Area of a kite is equal to diagonal 1 times diagonal 2 over 2. Well, diagonal 1 is 24 plus 7. Well, 24 plus 7 is just 31 units. Diagonal 2 is 7 plus 7, or 14. 31 times 14 will leave us with 434. 434 divided by 2 will leave us with 217 units squared. And that's our final answer. All right, next up, find the area. The hint is to use the altitude on hypotenuse. Now, if you recall, this is from Unit 6. I believe it's 6.8. Probably one of the least liked lessons that we've covered so far this year. So just keep in mind that this one's going to be a little bit more difficult. And if you recall, the altitude on hypotenuse is just drawing an altitude from the right angle to the hypotenuse. So as we can see, it'd just be this segment right here. So I'm going to go ahead and call that segment X. And when I do, I'll go ahead and draw it in red. When I do, it will create three right triangles that are all congruent. So each of these triangles here, they're all similar to each other. Not congruent, but they're similar. So that will allow me to set up a proportion. That proportion is long leg over short leg is equal to long leg over short leg. So it will give me 4 over x is equal to x over 5. 4 over x is equal to x over 5. And again, that's long leg over short leg. Sorry, long leg over short leg is equal to long leg over short leg. Cross multiplying, x times x is x squared. 4 times 5 is 20. So x squared equals 20. If I take the square root of both sides of my equation, I'll be left with x is equal to the square root of 20, or x is equal to 2 radical 5. Either one's fine. From here, I can use my area formula. Area is equal to diagonal 1, which is 4 plus 5, or 9, times diagonal 2, which is 2 times radical 20, over 2. And again, I got 2 times radical 20 because I have 2 radical 20s. So I have 2 of them. At this point, I see that we have a 2 on top and a 2 on bottom. They'll cancel each other out, leaving us with our final area as 9 radical 20 units squared. Of course, if we enter that into our calculator, we'll get about 40.2 units squared as our final answer. All right, our final problem of the day, we want to find the area of this rhombus. So first off, since I have a rhombus here, I know that I can use the area of a kite. So I can do diagonal 1 times diagonal 2 over 2. But since this is a rhombus, it's also within the parallelogram family. And if it's within the parallelogram family, I could either use that area formula that I just talked about for a kite, or I can use the area of a parallelogram, because technically a rhombus is a parallelogram. Well, if I use the area of a parallelogram, that would just be area is equal to base times height, or in this case, 15 times 9. Well, 15 times 9 will just leave us with 135 units squared. And that's our final answer. All right, guys, thank you so much for watching today. If you have any questions, please let